I firstly create the patient's file card with the name of the attending dentist, patient, and technician, and then click on OK to start the administration stage where I specify my restoration. A bridge restoration, crown abutment, i.e., the bridge abutment as a biogeneric proposal, and the intermediate unit, the pontic. I now select the connector. You can see the cross sections here, i.e., proximal surfaces or anatomical connectors. At present, anatomical connectors are integrated. If I wish to view a cross-section, I simply click on it once. I now select the milling unit. I confirm the material, zirconium oxide, with OK and move on to the scanning phase. In this case, I have scanned my preparation in the upper jaw, in the lower jaw, the opposing jaw. Buccal registration of the upper and lower jaw and add to catalog. Biocopy upper jaw. The in situ model or wax-up model. I then register the upper and lower jaw with the buccal scan. If the buccal scan is rotated through 180 degrees, I click on the lower half of the scan. This causes the scan to rotate automatically. I then drop it on the preparation margin, and it is automatically taken into account. The same goes for the lower jaw. In order to check the occlusion, I can click on the Analysis tool and check my model contacts by checking the contact points in the articulator. The model axis is determined next. I align mesially and distally along all three axes. I confirm with OK and am then taken to the preparation margin mode. I firstly have the option of trimming my model for tooth 24, as this is highlighted in yellow. Double-click to start, double-click to end. If the wrong area is hidden, simply click twice on the relevant area and this is displayed again. Draw the preparation margin. Double-click for the automatic preparation margin finder. If it cannot be found, press the space bar and draw automatically or manually. Press the space bar again for the intensity image in order to see a significantly clearer image of the preparation. The same applies for 25. In this case, drawing and trimming of the model is not necessary. Tooth 26. Manual drawing, since in this case I did not trim the model as the preparation is clearly visible. Correction of the preparation lines. And next, the bridge insertion axis. Here, the complete insertion axis for the bridge is determined. You can see a slight fault. Otherwise, everything else is OK. I then confirm with OK and have the possibility of generating my insertion axis for each stump. Using my crosshairs, I can also define the further insertion axis via the fourth axis. I confirm with OK and am taken to the parameter mode, where I determine the fit using the spacer. Initial proposal for proximal and occlusal contact strength. The minimum radial and occlusal wall thicknesses comply with the material manufacturer's recommendations, i.e., in this case, the minimum wall thickness of zirconium oxide is taken into account, as well as the margin reinforcement. If no margin reinforcement is desired, I can also reset this in the parameter. I then click on OK, and I receive a biogeneric proposal for all three restorations. You can see that the proximal contacts are still slightly missing. There is no complete gap closure. Slightly rotated though, we can still change that. Tooth 26 looks very good, except for the occlusal contacts. I will use my Form tool again, build up a slight contact, and then take a look at my cusps. It now looks okay. I will show the lower jaw too, perhaps, to see the intermeshing. I then take a look at the proximal surfaces. You can see a slight yellow fault. This is reduced to ensure a precise fit. I then activate tooth 25 and show the model for this. I now rotate the restoration and move it slightly into contact. I can do this by either moving it or using my Form tools. I add a small contact or shape tool, anatomical or circular. In this case, circular. Cusps, shape, reduce contacts. You can also move the cusps if desired. The same applies to tooth 24. I close the interdental spaces and reduce the contacts. If I am not happy with the anatomy of the restorations or with the biogeneric proposal, I can now change the anatomy with a right-click on Biogeneric Variation. Move the controller up or down. The occlusal contacts are imported again. With a right-click on Shape Tool Circular, I reduce the occlusal contacts. I do not spend too much time on the occlusal contacts, since this will be a zirconium framework and I reduce this occlusally, i.e. I click on tooth 24, reduce, and tooth 24 is reduced fully anatomically. And I move the controller to 1.3. Tooth 25 is not reduced from basal. Partial reduction. I draw the area. The orange area is to be reduced. To change the surface, simply click on Change Surface and move the controller up or down to obtain the desired reduction. The same applies to tooth 26. I could leave my proximal surfaces here to obtain the desired stability. Click twice and reduce the desired area. The connectors are then calculated. You can now see the proximal surface and the connector very clearly. I can then move or change the connectors. For this, I click on Move first. I move them slightly palatinally, changing the emergence profile, and then go to Edit Lines to change the emergence line. Double-click, and I can now change the emergence profile via Edit Lines. Double-click to conclude, or work with move lines or drag lines. For this, I right-click to select the area to be moved, and I can now simply move the emergence line on the desired area. I confirm this again with Apply, and I can now see the new emergence profile line. It is still a little thick, so I click on Shape and can now change the cross-section or anatomy. If the cross-section is too narrow, the connector turns red, i.e., I have to build up the material. When I have finished shaping, I can then go to the milling preview and see the block selection straight away. Next, I can select the block size in the milling preview. The block sizes that are too small are displayed. I could now select a 55, for instance, perhaps due to the height or width, and can pin mesially or distally. In some cases, it is a good idea for reasons of space to rotate or tilt the restoration in the block, i.e., if it does not fit. I can now mill the restoration in the InLab software by clicking on Mill. If I want to mill the restoration in the Stack software, I click on Export Selection and Stack Restoration. The restoration is now saved, and I can mill this restoration with other restorations in a block in the Stack software.